In this section of integration, we're going to look at how we can find the area between two curves. So, we have a curve in red here called G, and we have a curve in green called F. Now, in between these two curves, F and G, we have the area that we want to find. Now, noticeably, part of this area is beneath the x-axis, but I will show later that this isn't a problem. So, if we consider first the area underneath F, so we have this green area here, and then consider the area under G, we have this red area here. So, if we highlight this in blue, we have the area underneath F in green, then we can see that the area down here will cancel out because both of them contribute to that if we subtract the two. And then the area down here, where G is beneath the x-axis, that will give us a negative area if we integrate it without being careful, but if we're subtracting that area from F, then it's going to become positive. So by subtracting these two areas underneath the curves, we end up with the area between them, and we end up with the positive value of that. So, we can also show the reason we don't mind that part of it is beneath the x-axis by shifting both of these graphs up by the same amount. If we shift them both up by 4, then the area between them shouldn't change. So here we have F and G shifted up by 4, and we can see that their area is still the same. However, the areas underneath them have of course changed. The area underneath F is now this, and the area underneath G is now this reddish area. But by subtracting the two areas underneath the curves, we find that this part will cancel out, and we're left with the area that we want, the area between both of the curves. So, we have that the area between F and G is given by the difference between the areas underneath the curves and, well, between the curves and the x-axis. So if we subtract the integral of F, if we subtract the integral of G from the integral of F, we can in fact stick these two together because they have the same limits and are integrating with respect to the same variable, and we get the integral of F subtract G between A and B. So to find the more generally, this holds true for any curve, and bear in mind that we're counting as a line as a curve here. We have that the area is equal to the integral of y1 subtract y2, where our two limits are going to be where the curves intersect. Now let's take a look at an example. Here we want to find the area enclosed by the curves y equals x squared and y equals 6 plus x subtract x squared. So we begin by drawing a sketch, so we can see where these curves are going to intersect and where they're going to cross the x-axis. So we have the y equals x squared is going to look like that, but then our other curve we're going to need to factorize first so we can tell where it's going to cross. So we have y equals 6 plus x minus x squared. If we take that negative out as a factor, we've got negative x squared subtract x subtract 6. And then we want two numbers to multiply together to make 6. We can use 2 and 3. They'll have a difference of 1. So we have negative x. We want negative 3 and positive 2. So then we'll get our minus 1, minus x, and we'll get the multiplying together to make minus 6. So now we can see that the curve is going to cross the x-axis at when x is equal to 3 or x is equal to negative 2. So we have negative 2 and 3. So, to figure out what our limits are, we're going to need to find this point here where they cross and this point here where they cross, so that we can find this area in between them. So to find where the two curves meet, we just have to put them equal to each other. X squared is equal to 6 plus x subtract x squared. So that'll give us 2x squared subtract x subtract 6 is equal to 0. So this time we're going to factorize again, and we want to pair the 2 with the 2, so we get negative 4, and then we have a positive 3. And then we can multiply together to get negative 6. Negative 2 times 2 will give us negative 4x, and we'll get our terms. So then we have that x is equal to 2 or negative 3 over 2. So those are now our limits. So now we can integrate. We want to go between negative 3 over 2 and 2, and we want to find the difference between the two functions. So what we can do here is 6 plus x minus x squared subtract x squared with respect to x, which then gives us the integral from negative 3 over 2 to 2 of 6 plus x subtract 2x squared. Now this technique can be a lot faster, because then we're not having to evaluate two integrals and find the difference between them. We can find the difference between the two functions and then just evaluate one integral. So then actually integrating, we get 6x plus x squared over 2 subtract 2x cubed over 3. Between negative 3 over 2 and 2, and then we can substitute in our values. So this gives us 12 plus 4 over 2, which is 2, subtract 8 times 2 is 16 over 3, subtract, we have negative 3 over 2 times 6, which will give us negative 18 over 2, negative 9. And then we have 9 over 4 over 2. So we have 9 over 8. And then we have 27 over 8. And we've got an odd power, so we'll want a plus, so we have 2 times 27 over 8 all over 3, and then we want to be plugging this into our calculator, and this is going to give us 26 over 3 plus 45 over 8. Then adding these two together, we get 343 over 24, which is 14.29. And we are done. So, if you're happy with that, feel free to have a go at exercise 11D, or if you're feeling very confident, have a go at these questions.